Bridge. It's still there. It was built in the 19th century. London Bridge is in Lake Havasu City, Arizona. They have a new London Bridge in London. The original London Bridge, the people of Lake Havasu City, Arizona bought it for a tourist attraction. If you ever find yourself there, go look at the old London Bridge. It's not falling down, it's just fine. But it was older, so they replaced it. And there we go. Yes, question?
Yeah, I think I've been on a drawbridge once in America, but I don't know what it was called.
Yeah, we have them in America. The idea is, this is too low, and the bridge might, or a boat might hit itself with a big neck. So it picks itself up.
Commit suicide. That's why
Okay, the car's weight, etc. Now let's think about a drawbridge, and how long do these sides have to be for this drawbridge to work? Like, let's say, I'm making this up, I have no idea how long Tower Bridge is. I don't even know if this even makes sense. 100 feet. How about that? They probably do it in meters, but no matter. Let's say it's 100 feet. So, how long would they have to be? What do you think, Joseph? Okay, it could be 50 and 50, right? Could be. Maybe they're not exactly even. One is 75, 25.
Maybe one's 1 foot and the other's 99.
Yeah, Amanda?
maybe one of them is 0.001 feet, and the other one is 99.999.
I suppose that's possible. Is it likely? Probably not. Yes.
Maybe one is 1 inch long and the other is 99.11.
One is, all right, well, the point being, well,
perhaps
you
one of
guys,
them is 100 feet and the other is 0 feet.
that I don't think so, right? I don't think they're doing that. But the point being, it has to be 50, or it has to be equal. So when you add those two together, you want it to be the length, right? What happens if it doesn't add up? What if this one is only 25 feet and this one's only 25 feet? What happens? What happens? Huge gap, right? Big red bus comes down, those big red double deckers out in London, right?
Well,
Right
then you
in
don't
the
need
river
drawbridge.
Thames. Right in the river Thames. So a drawbridge, if you imagine it, it has to meet. Now what if now my drawbridge, they're 75 feet each. It's not going to close.
Well,
They're going to hit each other, right?
Yeah,
There's
then the
no
bridge
about
will
rubble.
kill itself because it'll have broken its side.
What's it going to make, though? If you picture this is what the span is across, if they're add up and they're bigger than this side, what's going to happen?
It's going to make a hill.
It's going to make a what shape? Come on, people. What shape? H I.
Now I realize.
Thank
Well,
you.
technically they're
Awesome.
imaginary
Also,
triangles.
if like say one's 75 and one's like even more than that, then it become, and it would also be like an exterior angle.
Oh, you're saying. Oh, okay. You're saying what if they meet like this?
One
That could
side-
happen too, I guess. Sure.
One side of the triangle cannot exceed the length of the other two sides that is together.
Oh.
Yes,
That's
ma'am.
in the PSCT guidebook.
Wouldn't like one of them be like just a little bit longer, like if there was 25 and
So they've got a future engineer here. So you're saying like they probably have a little bit of overlap when they meet, right? Yeah, I think you're probably right. In real life, they probably have a little bit of overlap, so like the cars can nicely, the lorries, yeah, you know, whatever they got running over there in
On the
London,
double carriageway.
can drive over it. But the point being, when we think about a triangle, we think about the side. So if this is a side, right, and these are other sides, if these two things are added, if it's less than this side, then you kind of have a drawbridge that's too short. They kind of flap in the breeze, right? If they are exactly the same size, then the two other lines just kind of fall on top of these lines. So you have to add them and get more. And that's basically what this whole lesson is all about. So if you're having trouble at any point, picture that drawbridge and picturing what those lengths have to be. And I think that's a really good way to think about it. Real quick, yes?
So you know that hill in the picture?
Which one?
The hill.
This one?
Yeah.
What about it?
Don't drive on the side of the bridge closest to you when you're going there. It's the right side of the road.
Yes, Joseph.
Don't drive on the right side of the road.
It's kind of like the Pythagorean
You
theorem.
drive
Also
on
like
the left side.
It's kind of an interesting observation. Why is it like the Pythagorean theorem? saying like A, B, and C? Now, that's gonna be true if they meet in a right angle, yes, sir. You do have the Pythagorean theorem. We barely even know anything about that. Absolutely, you guys make a great observation. So now we have your task sheet here. So I'm gonna, in a moment, I'm gonna give you a protractor. I meant to ask you to bring your own protractors today, I forgot, but I have some. So if you have one, awesome, use your own. I do have some, and I'll give them to you. And what you're gonna do, just hang on one second before you make a move. Let me explain what you're gonna do. You're gonna measure the sides, and then you're gonna measure the angles, and then I want you to order them from smallest to biggest. So, what do we get for AB there, Joseph? What, 1.5 inches about? Now, if you did this in centimeters, obviously it's a different number. 3.75 centimeters? Okay. How about like BC? I know, it's okay. We're gonna come back, and you can just join us in when you're ready. BC? BC, Lauren, is that your number? Yeah, what'd you get? About 2 inches for BC. And then how do we do with AC? Keely, what'd you get? Yeah, about 2 3/4 inches, 2.75 inches, something in there. So it says order these sides from smallest to biggest. So how would I do that? Yeah, Joseph? AB, BC, all right, and AC. For those of you that kind of finished that part of the task, do we agree on shortest to greatest in terms of side length? Okay. Oh, how'd the angles go?
I got exactly 180.
Me too.
You did. All right.
I
Measure of
see
angle
the-
A. Raise your hand. You got measure of angle A. Yeah, Kyle. Angle A. Let's look at angle A.
Angle A. Oh,
Angle A.
43 degrees.
How much? 43.
42.
Yeah, some people got 42. Some people got 43. Sometimes it's a little hard to tell. And you got 44. Yes. What angle B? How we do for angle B? What'd you get? Well, we'll split the difference there. We're around 105-ish. And what we get for angle C, what did you get, Abby? 32 degrees. Somewhere around here, if we add them up, we should get close to 180. That is part of the problem with using protractors, is when they're kind of in between, it can be a little difficult to tell. So these are good approximations, I would say. So the angle, smallest to greatest, what do we get? Who's smallest? Angle C, who's next? And then angle B?
Yes.
Alrighty. So let's see. So now what do you notice? There's a question there, right? What do you notice about the relationship between the sides and angles when they're ordered by side? Or is there a relationship? So our smallest side was AB and smallest angle is C. Smallest side is BC, smallest angle is A. Smallest side is AC, or largest side rather, and largest angle is B. Any relationship?
With each pair, like small, medium, or large between the two, it all has all three letters in it.
Yeah, so if it's AB, it was C. If it's BC, then it's A. But that's kind of cool. Does that help us in any way? Yeah.
They're all opposite.
Opposite. What do you mean by opposite?
Like in trigonometry, the opposite side, the opposite angle.
Well, what is that? Not all of us know anything about trigonometry
I
yet.
know what you're talking
So,
about.
but not everybody does. What do you mean by opposite angle? Because it doesn't matter if you're in trigonometry or not. What's an opposite angle? Explain it to me.
It's, the opposite angle is the angle on a side that is not, basically it's the angle that is not, the letter of the angle is not either of the two endpoints.
Let's see. Let's look at the picture, maybe.
I understand.
Well, let's look at the picture. Can you explain this to somebody who does not understand? That's what we're looking for. Can you explain it to somebody who does not understand what they
Okay, so if you choose, let's say any line segment, let's say 8 line segment,
Okay.
AB of triangle ABC.
Here's
okay?
AB. Yeah?
And if you notice, it's a small line segment. You know them.
What's its opposite angle?
So opposite angles, basically, you know how there's an endpoint there's only one endpoint of the triangle that isn't on line segment AB,
Okay.
and that would be point C.
I like the way she said that.
That angle is also the smallest.
It's not on this endpoint. So AB is opposite angle C. Now, we talked a little bit last class about opening the door, right? I was using that to kind of explain angles a little bit. So when you open the door at angle C, you get this distance, right? So it's opposite. The AB does not touch C. I like the way you said that. So if I'm looking at angle B, what's the side opposite angle B? Raise your hand if you think you know. The side opposite angle B. What do you think it is, Evan? AC. So you think you're opening the door, that's this. What about angle A? Who is the side opposite angle A? Side opposite angle A. Raise your hand if you think you know. Side opposite angle A. Nobody. What person knows?
Side opposite angle A?
Yeah, if you know it, raise your hand. Because if you don't, I'm going to be calling on you because now I got to talk to you. Okay, what? Right?
I'm raising my hand.
I know, look where people aren't raising their hands. Oh,
Hey, the
they're
person
lost.
behind you is raising their
Amy.
hand.
What? Oh, I know you know.
The
I'm
person
looking.
behind you is raising
I
their
see
hand.
it, I see it. But I see people who aren't, like Amy. So what is the side opposite angle A? CD? And here's why it's not. Here's angle A, and I think Amanda gave a nice description. It can't be touching, so B and A connect. So it's not going to be that. It's going to be the one that doesn't connect to it at all. Picture you're opening that door. How wide are you opening it? This wide. Kind of. Yeah.
So it's like kind of like shining a flashlight, I guess.
Yes, I love that.
I wanna open
It's
the
like
door.
shining a flashlight.
Okay.
And then, so this is kind of your field of vision now, right?
Yeah.
You shine a flashlight here, there's your field of vision. Shine one here too, it's a wider field of vision. Okay, that's a great way to, I love that. That's an excellent way to describe it. Yes, sir.
Can I have an overly long door too?
What?
Can I have an overly long door
I
too?
don't know what that means.
The doors are incredibly long.
Okay. But we're looking for, I think sometimes images, I love the idea of that flashlight shining. It gives you a picture, and hopefully that can make you see it. Because what's happening, C is the smallest angle, gives me the smallest side, AB. The medium one, which was angle A, gave us the medium side. And the largest angle, angle B, its side is, the opposite side is the largest side. So that's what, I think that's what I'm noticing, that the opposite, the shortest angle, right, that gives us the shortest side. I'm going to say opposite. And then the largest angle, that's going to give us, the side opposite is going to be the longest side. With the one that's in the middle, right, the medium angle, will give us that medium opposite side. So knowing who's the biggest angle helps us figure out, relatively speaking, where the sides are, and knowing how the sides are ordered will help us figure out the angle. So that's what we hope to get out of this. So here's some theorems based on what we just did. So if one side of a triangle is longer than another side, then the angle opposite the longer side is larger than the angle opposite. Like we stay up nights looking for the most complicated way to say things. So I think we came up with it. So I want you to remember either the door opening or a flashlight to remember who is the opposite side to an angle. And if it's small, if it's the smallest angle, this will be the smallest side. If it's the biggest angle, then this will be the biggest side. That's what that says. And this says it the other way. This one says start with the side and you can find the angles, sizes. And this one says if you start with the angles, then you can figure out relative sides. Yeah.
Can you never ask a flashlight there?
Yeah, you can, except not on the test if you want. Yes.
So basically, people figure out theorem, and then they spend forever thinking of the long, and then they spend even longer thinking of the most complicated way to explain it.
I don't know. All I know sometimes it's hard. I found this little interactive triangle thing. I thought it was kind of neat. So if you play with the different sides and angles, you can always see, here's my smallest, oh, look, is it just it? What's happened here? Oh, because I'm rounding the side. Let me make that much different. Okay. So, no, they're all different. The smallest angle, if you look at the side opposite, is going to be the smallest side. The biggest angle the side opposite will be the biggest side. So, you can play around with it, it's still gonna like you're just like, ooh,
Let's make this unique triangle. Let's just
so,
make it straight.
and I like this one also, it gives you relative size of the angles, so you can see it here as well.
Straight line.
Okay. That's nice. Alrighty. Ladies and gentlemen. Let me see, I don't think this example is on here, but let's just look at the example over here. What is the measure of angle A? Great question. So if this is 115 and this is 29, first of all, how do I find the measure of angle A? Yeah? Yeah, how do I find it? Right, I'm going to use the triangle sum theorem plus the measure of angle A. Oh, and I've got to add all these numbers, so let's see, is that 144?
It's 36.
It is? Okay. And that equals 180, subtract that, it looks like the measure of angle A is 36. Is that right? Okay. That's awesome, now I know all the angle measures. Now that I know all the angle measures, what's the longest side of this triangle? Joseph, what's the longest side? AC, how come? It's opposite the biggest angle. Because that's the biggest angle, that's the biggest side. What is the shortest side of this triangle? Yeah? AB, why? It's opposite the smallest angle here, so that's this one. And then our middle length would be, this is our middle angle, so BC will be our kind of middle. So if I wanted to write an inequality that describes the order, so inequalities, I'm going to write a compound inequality. They kind of work like the number line. You have your smallest numbers leading up to your biggest numbers. So the lengths of the sides, my shortest side is AB. And it is length than the length of my middle side, which is BC. And that one is smaller than my shortest, or my longest side. That's how you would write it as an inequality. You basically write it in order from shortest to biggest, and you can put less than thing. So that's that. And then I just want to point out that I can tell, relatively speaking, who's shorter or who's longer, but this does not give me any indication of what their actual length is. I just know, relatively speaking, they are in this order of smallest to biggest. Yes, sir.
You can't figure out the lengths of the entire triangle is in one side and one angle.
Do I know one side?
If you know one.
Do I know one side?
No.
No. I can't do it. So this is just giving you relative ordering. That's all this is doing for us. Okay, so you've got some examples here. Let me see what we want here. We're going to list shortest to biggest, okay? Now this time they've given me sides. So what's my smallest angle for this guy? The smallest angle. Yeah? Which one? E? How come E? It's the shortest segment, so I look for its opposite angle over here. So that's that one. What's next? That's my middle angle. We need more than one person trying to get this, so Abby, what do you think? Angle B. Why? So that's my middle length. So I look at the opposite angle, I know I'm D. And then this is my biggest length, so angle F is the largest. Now I've got some angles. So what about sides? Now I'm going to order by size. So what's my shortest side here, Joseph? I'll call it AB just because I can't help myself, a BA, because it's opposite the shortest angle. What's the next one, Amanda?
1 segment AC.
Correct. Because that's my middle angle measure, so we go across from it. Here's my biggest angle, so BC will be the biggest side line. So far, so good. Questions, please ask if you have them. If you're like, what? Now this one's kind of a curious one. So I've got x plus 2, x plus 4, and I want you to order angle 1, 2, 3 from shortest to biggest. What? What do you think, Maya? Angle 2 is what? The smallest? Why? one, right? So then that angle 1 is opposite that one. And if you add 4 to x, that's going to give you your biggest number. So that one would be, angle 3 would be this. Does that make sense? Right, relatively kind of looking at things. Yes, sir?
This person is either a terrible artist or x is not equal to 1.
What?
This person is either a terrible artist or x is not equal to 1.
Why not?
Because if a person was a terrible artist, it would be assumed that if he was a good artist, then one and
Yes,
two would
the thing to
probably
remember
be
is
fine.
never look at them and assume anything by what it looks like. They assume they're all terrible artists or whatever. Don't assume anything by what they look like. Alright, now we're going to do an interesting one on test 2 here. You definitely will need another piece of paper here. And for this, you're going to need a compass. Before I give them to you, then let me show you how they work. Okay, hang on. Just watch for a moment. Here's my compass. I am horrible working with these things, but I have to. I like using the ones by hand. I don't like the virtual ones. In a moment, what you're going to do is this. To copy a line using a compass, you use the straight edge, and you can use your protractor for a straight edge. And you're going to draw a line that looks a bit longer. Then you take a little pointy bit of a compass, and then you're going to spread it as far as you can to reach that other end. And this is the length of that line. Now, without changing how far this is open, you're going to put the edge here, and you're going to make a line. Oh, I didn't do that because I don't like this thing. I'll move it too much because I don't really have to move it that well. Okay. So I go here, and then I'm going to make a line for 11. So from here to here exactly measures here to here. If I want to make a triangle, now I'm going to measure the other side. Watch this from here. I'm going to measure the other side. Let's see what this works. And then that measures that one. Now what you're going to do is put this here, and you're going to make a giant arc. I mean, except not like that. This way. Make a big arc. Then you're going to measure your third side. And so now I have to turn this around somehow. I think that way. Yeah, just don't worry. I'm going to help you when you have an actual compass, but this is generally what you're going to be doing here. I don't like these electronic ones. I really don't understand. Just hang on. I know. Let's see. That has to equal that measure. Then I'm going to put it here. And I'm going to draw this. Now what I have here is at this point, you're going to connect this line to this line. And you can connect that line to that line. And you'll have used the sides of the triangle. So this is your little challenge for today to kind of figure that out. When you figure that out, I want you to construct a triangle with FAC. And yes, cat and fish. Cats are better than fish. Just say. All right, so wait. I don't like this little tool. I like working with the real thing, but what can I say? So it's all I got. So if I measure this one here, I'm going to try and make a triangle SFA. Okay, so I'm going to move this here. And it's okay if you didn't do this one, you just want to watch. So I'm going to make my arch for this side. So now it's like going, okay. And then I have to measure this side, which means I have to turn it. Okay, I'm just measuring.
It doesn't reach.
It doesn't work.
It's your
All
leg.
right, let me go back.
You will fail the course, Evan.
Maybe both.
Yeah.
Failed
All right, so
your-
now to make this side.
Oh, no, I did it wrong.
Oh, wait. Mine's not working either. Look, wait a second. Look up for a moment.
Okay, yeah, that's what I got.
All right. So when I made, I tried to do, here's my one side. This, so that would be, F. And so I'm trying to make this one. That arch went here. That arch went here. They don't meet.
You
What
did
happened?
something wrong.
I did something wrong? What? Why not? It just can't, right? Could you create
Because of
both
your fault.
triangles? No.
No.
Why or why not? She says because you just can't. Why can't I? What's your idea?
But maybe because segment FH and HS, when you add them together, are greater than FS.
Oh my goodness. This is the Tower Bridge problem. This is Tower Bridge. If they didn't make the length of it long enough, and they've got like, you know, the big red buses and the big black taxis like falling into the Thames. Well, the sides aren't long enough. Sides aren't long enough. So any three segments will not necessarily make a triangle. Why not? Other two sides, right?
I don't know what to do.
I did it for you because this one was hard, so I did this triangle for you. The other two sides.
I don't know what to do. How do I do it? What's problem? How?
The sum of two sides of a triangle must be bigger than the length of the third side. That's what's happening here. This is our tower bridge issue. If your drawbridge is too short, they won't meet, and you have this kind of gap here. So it has to be bigger. If they're exactly the same size, that is a drawbridge. But I'm looking for a triangle, so they need to be bigger. Add the two sides, they need to be bigger than the third. Let me go to this side. So let's just look at, I got some of these, remember these little tinker toy things?
Oh, you're not.
Yeah. So if you look at these different rods, which ones can make a triangle and which ones can't? So I have a red, a green, and a blue, and they made a nice triangle. But if you take looks like two yellows and I don't know what that one is. See how they're not long enough? If you add these two lengths together, they're smaller than the length of the third side. So again, another image of when triangles work and when triangles don't. I mean, does that make sense at all? Because we can explain a little bit more if we need to. And we'll be looking at other examples here. So this is the triangle inequality theorem. It says the sum of the length of any two sides of a triangle is what? What do we think goes in that length? Greater than the length of the third side. Thousands. Okay?
Oh.
So, but this one, again, if they make sense, they're not hard to remember. I picture that drawbridge. To me, that makes sense. So it says that AB plus BC, you add those numbers together, it's going to be bigger than AC. If you add AC and BC, those two have to be bigger than that. And if you add AB and AC, it has to be bigger than BC. So, let's see, I've got a couple of examples here. I'm trying to see where I am here. Yeah, I'm towards the bottom of page 1, which says, is it possible to have a triangle with sides 5, 6, and 12? No, why not? Right. So 5 plus 6 is 11. So if you picture it, this one's 12, this one's 5, this one's 6, they're not going to reach. So I can't because 11 is less than 12. It needs to be bigger. So it won't fit. All right? Makes sense, not make sense? Makes sense, okay. A triangle has one side of length 12 and another side of length 8. I want to find the possible values of x that could be the third side. Well, so I'm going to draw some different pictures of it. One's 12, one's 8, one's x. So if I look at it this way, that means that this plus this has to be bigger than 12. That's what my theorem states. X plus 8 has to be bigger than 12. So I subtract that 8. That means here that x has to be bigger than 4 for triangle 4. But I can kind of turn it around a little bit. I could be looking at this is the third side and I add these two numbers. So 12 plus 8 also has to be bigger than x. So 20 has to be bigger than x. So let me just show you a little trick with these. When they say x has to be between what to be a third side, here's what you do. You put x in the middle and you make these little, I'm going to make the compound inequality. You subtract. What's 12 minus 8? Then you add 12, 8 plus 12. And this is the range of values for the third side. It's a number between 4 and 20. So if it's 21, won't work. If it's 3, won't work. And if it's 4, it won't work. It has to be bigger than 4 and less than 20. Strictly bigger, strictly less than. Okay? So that's kind of the secret to doing those easily. So I've got a couple of U-tries here. Let's just try it together a little bit. Can I have a triangle with 6, 7, and 11? So we add 6 and 7, that's 13, it's bigger than 11, right? Add 7 and 11, 18, bigger than that. 6 and 11, bigger than that? Yes. Sometimes it's easier to order them. I like doing this, I order them by smallest to biggest. I can see it a little bit easier. How about this one? Can I make a triangle with this? These three sides. Why not, Kyle?
9 would be over 20.
Well, they're not more than 20, right? It's less than 20. 17 is less than 20. I'm going to have my drawbridge problem where the bus is going for the third times here. How about 3, 6, and 9? Can I make a
Those would be
triangle with
fine.
3, 6, and 9? No?
No,
Why not?
it's exactly 9.
It's exactly 9. This is a drawbridge. This is where you have 9, and those two sides will meet right where they need to meet. It's not a triangle. So it has to be bigger. So if that was a 4, great, but it's not. This is where we want to explain the third side. What's the range of values for the third side? This is where we put an X, our inequality. Subtract and add. You try big. Okay, so I'm on the bottom of page 1 here. You tell me the range of the third side there. This shouldn't be hard. And you think you know what it is. What do you think it is, Keely?
It's 6 is less than X,
So right, you just subtract, you add, that's the range of sides. And that can sometimes help you with these, subtract and add and see if the other side fits in there. All right, last bit here is, we're not gonna do this investigation, I think we've done this one to death. We're gonna look at the Hinge theorem and its converse. So this is opening the door, it's all about opening the door. So it's the most complicated looking theorem ever. Blah, 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 blah. I can't even read it. Here's what it's basically saying. So if you have kind of angles, and these sides have to match, that's important. See how this in between here is called an included angle, meaning it's in between two sides. And they're congruent, corresponding congruence, right? The angle in between, picture it opening a door. Which side is longer, XW or ST, based on angle measure, not looks. Based on angle measure. Who's longer? Who opened the door wider? Yeah. Because this opened 88 degrees, this one will be longer than this one. It only opened the door 35 degrees on its hinge, right? So that's why they call it a hinge theorem. Important bit is that you have to have this congruence condition. And if you do, you just look at the angle to decide who's bigger. Yeah.
Why don't you just say that?
Because they're trying to be very thorough, and sometimes being thorough makes it sound complicated. This one is kind of working with the sides now. So you have the same issue where the sides are congruent. Now I don't know the included angle, but I do know the sides opposite. This side is 12, this side is 9. Who's bigger, C or F? Who had to open the door wider? Keelan? C. Because this door got opened wider than that one, this degree measure must be bigger than that degree measure. And that's the Hinge theorem and converse. So we have a few examples here. I'm on the back here. So, oh goodness, look at this. AC is right here, okay? And EG is right here. I'm looking at side lengths, 14 and 16, 14 and 16. So I have the condition with congruent sides. Both of them are 32 degrees. So what can I say about AC and EG? I open the door the same for both. So what do I say for this one and this one? Are they equal, less than, or greater? Yeah, equal. Let's look at AB and FG, okay? 16, 16, 16, 16. So I have my congruence condition. This one opened the door 100 degrees. This one opened it 116 degrees. AB is less than, bigger than, equal to FG. Yeah, less than. I didn't open the door as wide, so this doesn't get as big as this one where I open the door wider. Okay, that's the general idea with these. The BE is 12. This one's 12, and EG is 8. And what do I know about these angles? Again, 16, 14, 16, 14, those match. Who's going to be bigger? This angle here, BDE, or this angle here, BDG? This one or this one? BDE, right? So that one's bigger because I opened the door wider. if EG is 8 and CF is 8, again, these measures are the same, what can I say about these two angles? Less than, greater, equal, which is it? Okay, open the door, I opened the door to say, so what do I say? Those measures are gonna be equal, right? Alright, so I do have a couple of tries here. Give it a shot. I'll put the answers up so you can check, and I do want to hand out homework, so I'm gonna review that.